In this video, we're looking at an integral that has the basic form of an inverse tangent integral. And what I mean by that is that we have 1 over 1 plus a variable thing squared. And then in the numerator, we have the derivative of that variable thing. So our variable thing is the cosine function. The derivative of that is the sine function almost. We'd have to throw in a minus sign and compensate out in front. And we could handle the chain rule backwards informally, but in this problem, I actually asked my students for an explicit u substitution, including the transformation of our limits of integration into u space. So what we're going to do is let u equal cosine x, and that means du is going to be negative sine x, that's the derivative of the cosine function, times dx. Now we still have to transform the limits of integration, so we just want to forget about x here, and we move the entire integral into u space. So we look at the lower limit and we say when x is equal to 0, what does u have to be? So I look at my original substitution and the cosine of 0 is 1. Then we look at the upper limit when x is equal to pi. And the cosine of pi is negative 1. So we have an upper limit of negative 1. So this is kind of interesting because it forms a backwards integral. So I end up with the integral from 1 to negative 1. Again, that's a backwards integral because our lower limit is a larger number than the upper limit. And this numerator is negative sine x dx. Well, that's just du. And then the denominator is 1 plus u squared. So it's not like the backwards limits of integration cause a significant problem here, but we can change that by applying this minus sign out in front. If you reverse the order of the limits of integration, it produces a minus sign. So we can rewrite this thing as the integral from negative 1 to 1 with no minus sign of du over 1 plus u squared. Now this is exactly the form of an inverse tangent integral. So this integrates to the inverse tangent of u, and we evaluate from negative 1 to 1. And it's really important to be able to read this when we're talking about inverse trig functions. When I apply that upper limit, it says the angle whose tangent is 1. In the lower limit, I have the angle whose tangent is negative 1. And then we're kind of visualizing the unit circle and trying to figure out, well, what is the angle whose tangent is 1? And that's pi over 4. And the angle whose tangent is negative 1, that's in the fourth quadrant, where the sine function is negative, the cosine function is positive, but they have equal magnitudes. So that's an angle of negative pi over 4. And we put together pi over 4 minus negative pi over 4 to get pi over 2. And that's it for the problem. I do want to apologize for my voice being like an octave lower than usual. I am suffering from the flu right now. But late in the day, I decided I was good enough to actually be able to speak again. So here we are.
If you enjoyed this video, or at least found it useful, check out another one by clicking one of the links on the left. Or click the Zach's Lab logo on the right to explore dozens of physics and math playlists. As always, you can leave your questions, comments, and requests in the comments section below, and I'll get back to you within 24 hours. Thanks for watching Zach's Lab, and best of luck on your math and physics journey.